Everybody's doing good today. This is our first lecture video for the semester. Before we left, we had finished the first 3 out of the 4 sections from Unit 2. The only one we didn't really cover was the word problems. So I drew up this practice quiz. It's available to you on Canvas. And I want to just go over maybe 2 or 3 of these examples. And then the key will be posted later today. If you have other questions, certainly let me know. I'll be making another video for our review, probably later today or early tomorrow. So please send me an email if you have specific questions you want me to go over on the study guide. So this section is all about word problems. And the most important thing in these word problems is the setup. Once I give you the setup, the chances that you get it right are much, much higher than if I just give you the problem by itself. So what we're going to focus on mainly today is labeling the variables and the tricks behind labeling the variables so that we come up with a system that's going to work no matter what the problem looks like. So let's start with these first couple. Oh, sorry, my camera's not hooked up. There we go. So we wanted to look at these word problems, and like I said, the main thing I want to do is look at the labeling of the variables. So let's start with number 1. Number 1 told us during the 113th session, the U.S. Senate had 98 Democrats and Republicans total. So from that sentence, I know something like Dems plus Republicans is equal to 98. Then they gave me another sentence in here that said something like, there were 6 more Democrats than Republicans. How many of each party were there? And this is where we go into the process of labeling the variables. So what I'm going to do is down here, I'm going to put Democrats equals Republicans equals. And we want to label these variables in the following way. In each of these problems, there is a sentence that gives us a description of one thing related in terms of the other. And here it is were 6 more Democrats than Republicans. In this sentence, they're describing the number of Democrats relative to Republicans. So the one that they're not really describing in detail here is Republicans. For all of these problems, the one that's not being described in great detail is the one that we want to refer to as X. Once we do that, we can go back to the sentence and we can find out how we want to write out the original part of the description. Or in other words, we want to write out how they're describing Democrats now. So in other words, if Republicans is just X, and we know there were 6 more Democrats than Republicans, then our Democrats is going to have X as well, but we need to add this additional 6 value in here. So the way that we express Democrats in here would be X plus 6. Now, going back to that first statement that we wrote, we know that the number of Democrats plus Republicans has to be 98. And now we have an algebraic expression for Democrats, an algebraic expression for Republicans. We can plug it in and solve. X plus 6 plus X is equal to 98. And then we solve for X. We combine like terms. I have one X here and another X here. That gives me 2 of them. So 2X plus 6 is 98. Now it's just a 2-step equation. We solve for X. Subtract 6 from both sides. We get 2X is equal to 92. And dividing by 2 gives us that X is equal to 46. 46 senators. All of these word problems should have some sort of a unit or word attached to it, not just 46. 46 what, right? That's part of it. The other part is we're not done when we solve for X. And this is the most important part of the problem. We have to make sure that we take this value that we found and we plug it back in so that we can get the true number of each of these. Now, in this question, it asked how many of each party were there. So we need to know both values. On the exam, it may ask you for one or the other. So it's really important that when you get here, you don't stop or you don't call your answer 46. Go back, plug it into the context of the problem, and then answer the question. So for Democrats, we're going to have 46 plus 6, or in other words, there were 52 Democrats. And for X, for Republicans, it's just 46. We don't have to add or subtract anything to that number. So we had a total of 52 Democrats and 46 Republicans. Like I said on the exam, they may have a problem very similar to this, but then at the end, they're only going to ask us maybe for one of these two values. So just be very careful in your labeling once you solve for X and you go back and you plug in. On all of these problems, I like to have this piece written out just in words and the algebraic expression that goes with it. That way when I solve for X, it's much easier for me to plug back in. So number 2, I'm going to leave for you to do on your own. It's very similar to number 1. You have a dog and a cat, combined weight of 84, and then it has a dog that weighs 3 times as much as a cat. So you'll be setting up the expression for dog, the expression for cat, and then adding those together to get 84. I will do number 3 though. Number 3 says a Major League Baseball team plays 162 games in a regular season. What's missing in this statement would probably be really nice is all games are either won or lost. So you can't tie in baseball. If a Major League Baseball team lost 3 less than 4 times as many games as they won, how many wins and losses did they have? Okay, so we know right off the top that you can't tie, so the number of wins plus the number of losses is going to equal 162. And then we want to set up an algebraic expression for wins and an algebraic expression for losses. So let's go back to that second sentence again. It says, if an MLB team lost 3 less than 4 times as many games as they won. So the one that they're not describing in great detail here, sorry, I need emails. So the one they're not describing in great detail here is the number of games that they won. All of this description is talking about how many games they lost. So wins, in this case, is going to be our X. Losses is the algebraic expression we need to build. So it said an MLB team lost 3 less than means to subtract 3 from a value. 3 less than 4 times as many games as they won. So the losses, 4 times a value is going to be our 4x. And 3 less than, remember we know to always put the subtraction on the end, right? So this is going to be minus 3. Going back to just make sure it looks good. An MLB team lost, so this is the description for lost, 3 less than 4 times as many games as they won. Cool. Now we can take these two expressions, we plug them in, we solve for x. This is x plus 4x minus 3 equal to 162. Combine like terms. Remember that this is a 1x, so we have 5x minus 3 equals 162. And I assume from here you're probably pretty good. Add 3, divide 5. Don't forget at the end you're going to have x. I want you to go and plug it back in to give me wins, plug it back in to give me losses. I really like this problem, by the way. This looks like a good problem to put in terms of word problems for the exam. I will tell you, though, that if I do put this on the exam, I'm not going to ask you for both wins and losses. I may ask you for one and not the other. Again, stressing the importance of once you solve for x, you're not done. You got to go and plug it back in and make sure that you're answering the proper question. In this one, you might solve it, get x equals, I don't know, 35 or something. And then I could ask you how many losses they had. So you're not done when you get x equals 35. You got to go plug it back in into the losses expression and make sure that you get the true value. Lastly, I want to do a distance rate time problem. Not 100% sure if I'm going to put a distance rate time on the exam. I'll tell you during the review, though, for sure, one way or the other. But it's important to know how to do them. So remember, for all distance problems, 2 trains leaving a station or 2 cars leaving, all these type problems, these all deal with distance, rate, and time. And the most important thing we need to know about that is that distance is equal to rate times time. If I decide to go on a long drive today and I average 50 miles an hour for 4 hours, I will have gone 50 times 4 or 200 miles at the end. And so multiplying how fast you're going times how long you're going is going to tell you how far you went. I use this in a nice little chart to solve distance, rate, time problems. It told us 2 cars leave Las Vegas at 9 o'clock and travel south on I-15. So both cars are heading in the same direction. And we have 2 cars. We have car A and car B. So we'll label them on the sides here. And we're going to put in all the information for car A on the top row, all the information for car B on the bottom row. In this particular instance, we don't need the very bottom row. We're just going to use the top row and the middle row. Sometimes we want to know the total, and we use this bottom row as well. Not needed in this particular problem. So we can fill in as much information as we know. In the beginning, it told us car A travels at a constant rate of 65 miles an hour. So for rate and car A, I'm going to put 65. Car B travels at a constant rate of 83 miles an hour. Damn, car 3 is flying. In how many hours will the distance between them be 24 miles? So let's actually talk about this. Maybe we do want a total bar. If 2 vehicles are traveling in the same direction, one traveling faster than the other, at a certain point, we could stop the clock and find out how far apart these 2 are by subtracting. We want to take the long distance, I'm going to call it D1, and from that we would subtract the short distance, D2. So the car that's moving faster is going to have traveled a longer distance than the car that was going slower. So what we want to do, if we want to find out how far apart they are, we're going to subtract these 2 distances from each other. What else do we know about time? It says, in how many hours will the distance between them be 24 miles? In how many hours tells us that what we're looking for in this problem is the time. We don't know what the time is. So I'm just going to refer to that as x. For the distance column, though, we can multiply these values together. Remember that rate times time is equal to distance. So 65 times x is going to be written as 65x. And 83 times x is going to be 83x. Remember, we want to subtract these 2 distances from each other, and because car B was going faster, it has a longer distance, right? 83 being larger than 65. So the distance between them we can write as 83x minus 65x. This is the distance that goes in between those 2 cars. And we want to know, when will that distance be equal to 24? 83x minus 65x is going to give us 18x is equal to 24. Then we divide both sides by 18. And we get 1 1/3 hours. Or 4/3 hours if you wrote it as an improper fraction. As a mixed number, I'm going to write it as 1 1/3 hours. Remember that 1/3 of an hour is equal to, if I multiply this number by 60, because there are 60 minutes in an hour, I can see that 1/3 times 60 is 20 minutes. So 1/3 of an hour is the same as 20 minutes. You could have actually started with 1 hour is equal to 60 minutes and divided both sides by 3 in order to get this relationship. But what this tells me is that the time is going to be 1 hour, 20 minutes. Be careful about answering the question in the right context, though, because this question told us in the beginning the cars leave at 9 a.m. and we want to know, In how many hours will the distance be between them be 24 hours? Well, in 1 hour and 20 minutes, we found out the proper answer to that first question. It says, what will the time be then? So remember, they left at 9 a.m. And so adding an hour and 20 minutes to 9 a.m. tells us that the time is going to be 10:20 in the morning. Don't forget to put your a.m. It's not going to happen tonight. It's going to happen this morning. The last thing we can do is answer these other two questions. How far will car A have traveled? How far will car B have traveled? That's going back up to our chart up here and plugging x in place of the distance for each one of these values. So we can plug in x into car A's distance and find out how far car A went. We could plug 1 1/3 into x for car B to find out its distance as well. So just to wrap it up, car A's distance is going to be 65 times 1 1/3. And we can see 65 times 1 1/3 is 86 2/3 miles. And for car B's distance, that's going to be 83 times 1 1/3. Which is 110 2/3. And just as a check, we can verify that these two values that we just found are exactly 24 miles apart. That's it. I'll leave it to you to try number 5. The setup is going to be very similar. In this case, though, there's one major difference. When two values are going in the same direction, like the one that we just saw, we subtract. However, in the next problem, they tell us that the two boats are traveling in opposite directions. So because they're getting farther apart from one another and going in opposite directions, we actually add those two distances together. Visually, it looks something like this. So the opposite directions, if they start in one place and one boat goes this way and the other boat goes this way, for example, if one boat goes this way, I'm calling D1, and the other boat goes this way, it's distance D2. If I want to know how far apart they are, I would add these two numbers together. So this is for opposite directions. We add the distance together. If they're going in the same direction, like the one that we just saw, maybe here is D2 and I don't know, here is D1, going in the same direction, just different speeds, then we subtract. Okay? And that's it for the word problems. Like I said, go through these 5 problems, make sure that they look good. By, I don't know, later this afternoon, no later than 2, this key will be up and ready for you guys to take a look at. And send me an email if you have specific questions you want me to go over during the review tomorrow. And again, I'll have office hours available Friday morning before your exam. Have a great rest of your day.